Good morning, everybody. It's great to follow Professor Eugene's talk. So my name is Anderson Shum. As kindly introduced by Joe, I'm currently at the City University of Hong Kong and also president of Hong Kong Young Academy of Sciences. So I'll start by just giving a very brief concept of my research and then talk about my own research journey. And then I'll share with you how maybe involving in scientific project in science in high school really impacted on my life. So yeah, I was born and bred. I'm a local from Hong Kong. I did my primary school, secondary school in Hong Kong, and then I went to the US for my undergraduate degree from Princeton University. And then I got my master's degree and PhD degree from Harvard University. And then afterwards, I came back to Hong Kong and started as an assistant professor in mechanical engineering at the University of Hong Kong. With a lot of support and help from senior academics, the Hong Kong government, I had the opportunity to lead an innovation center at the Advanced Biomedical Instrumentation Center in Hong Kong Science Park since 2020. And since last October, so just 4 or 5 months ago, I moved to City University of Hong Kong. And now I'm serving as the Vice President Research. So my research is in the topic called microfluidics. Microfluidics is to use small channels and direct fluids to flow in these small channels and use the fluid inside to do useful things. So most of the applications we focused on in my group is related to biomedical. So I'll start by introducing why microfluidics and droplet microfluidics may be useful for biomedical applications. So I guess a lot of you are using computers, are using kind of your phones, and these were all facilitated or enabled by digital transformation of the society. So basically, instead of getting continuous information, like between 0 to 100 in a continuous scale, by converting information into digital formats, meaning zeros and ones. This is called digitization. It's behind the transformation of many modern technologies. So to do diagnostics or to do detection of diseases, very often we also have been starting mostly with a continuous scale of the signal. For example, maybe if you want to see whether you have certain diseases or during COVID, you may have seen or done a lot of these tests. In the past, what people were doing is you take some samples, maybe from your blood, saliva, sweat, urine, etc. And then you may measure the concentration of certain markers. If you have a high concentration of certain markers, maybe there's a high association with you having contacted or having been infected with certain diseases. So you have to be able to measure the concentration or the intensity of the signals. So this has been very useful, and you need to have very sensitive detectors to detect signals. So so let me use an example of this. So basically, one example I like to use is if you are very early during the disease infection, the concentration of the markers may be very low. If the concentration of the markers that indicate whether you get the disease or not is very low, either you have to have very sensitive detectors, which is not always not easy to achieve. You always, even with you work with the state-of-the-art detectors, may be very expensive, and still maybe you can only do it up to certain concentration level. And so if you want to detect the disease much earlier, you have to have more and more sensitive detectors. And there's only so much you can do. So one analogy that I like to use is, let's say if you go to the Victoria Harbour, the harbor that we love with the loss of water, you want to see whether there's any fish inside the Victoria Harbour. If you just take a lot of the water from the Victoria Harbour and you try to detect whether there's any fish inside, so most probably you will not be able to detect any fish inside because the concentration of the density of the fish may not be high enough that you can just detect with a not very sensitive detector. But doesn't mean that it doesn't have fish. It just means that it may be present with such a low density that you need other method to detect them. So one of the things that we try to do in our research is, instead of just taking a sample of the water and seeing whether there's fish, or instead of taking vial of a of a solution with color dye, and because the color dye may be having very low concentration of the color dye, so if you just try to see whether you can see color, you may think that it's transparent, but maybe it has some dye, but the dye may just be at such low concentration that you cannot see them easily. So what we do with microfluidics, or with droplet microfluidics, is essentially we want to take this color dye solution and break them into lots and lots of small droplets. So each of the dye is a molecule by itself. So if you reduce the size of the solution that surrounds this molecule, meaning that if you just have one molecule, but if your solution is at a very large volume, then you may not be able to see the color. But if you reduce the volume of the liquid by significant amount, for example, you break your solution into 10 million or a billion droplets, then most of the droplets will be empty. We will not have the dye molecule. But the droplet that has the dye molecule, you will have a high concentration of the dye in the droplet. So this is what we do, what we call by digitization. So instead of measuring the signal continuously, we try to break the signals into lots of zeros and ones, and then you can count the number of droplets that has the ones, that has the dye molecule. So this is what a major part of what our research is about. So if you can break your body fluid, your sweat, your blood, your urine, and others into millions and trillions of droplets, then you can start to detect whether you may have certain biomarkers inside these droplets. And if you do have them, then you can see something like this. Most of the droplets that you form will be empty. You don't see a color. You don't see the green color. But the droplets that has the signal will have a more intense green color. Then you can start to detect at a much earlier stage, even though the concentration of this color dye is lower, but you can start to measure the amount of the dye or amount of the biomarkers by digitizing or by breaking the sample into droplets. So this is one of the major part of what my research is about. So now I'm going to get a little bit into my own research journey, not so much about my research, because I like to also share with you how I have benefited from the great ecosystem and the environment in Hong Kong to inspire me to become a scientist. So since I come back to Hong Kong, I have been very blessed with a lot of support and recognitions at different levels, ranging from private charitable organizations such as the Croucher Foundation that gave me the Croucher Senior Research Fellowship, all the way to our National Chinese Academy of Engineering that gave me the Guanghua Engineering Science and Technology Prize. So I've been very grateful to the environment in Hong Kong and in our country that that have allowed me to grow. But it all started, as my title said, it all started from high school. So my first research experience was during summer after high school. I was 19 at the time. This was my experience I was joining a summer program in a university, Technion University. It's an institute of technology in Haifa in Israel. So it was a program for secondary school students. I had the opportunity to be surrounded with different secondary school students from different parts of the world, and we were each engaging in a research project. There may be groups of 2 or 3. I was working with another student from Bulgaria, and I was working on the project of the effect of noble metals on photocatalytic efficiency of titanium dioxide. So that gave me a first glimpse of how research is like, what it takes to do research, how to use certain new equipments, and how to start thinking about research in a scientifically rigorous manner. And then afterwards, when I was doing my undergraduate studies, I also did some summer research. I actually came back to Hong Kong for my summer vacation, and I was participating in a summer project following the close mentorship of some PhD student and also postdoctoral researcher at the time. I was learning how to use certain equipments, spectroscopy, and how to measure catalytic activities, etc. So this was my other summer research experience. And then afterwards, I also did a summer research experience over the summer during my summer holiday at Harvard. It was a materials research program that allows some of the undergraduate students to be pursuing summer research. So you can see that much of my research journeys have been guided by lots of opportunities that have been offered to me as a student assistant, summer students, giving me exposure to different research fields, different research environment, different style of supervision, different research topic, different research tools that are being used in different research projects. So all of these really gave me the exposure that have shaped my research career afterwards. And of course, the friendship and the network that I have built during the summer research experience also gave me a lot of advice on what I should be doing, what I would need to do if I want to achieve certain research career objectives. So these were all very helpful. And even many years after my summer research experience, when I went to materials conferences, I still sometimes bump into some of my mentors, some of the administrators of the summer program that got me into research, and we still maintain good friendship. And that's one of the great things about doing science. You make a lot of friends with a lot of very intelligent and nice people that you can, through the language of science, through the language of belief in how science can make the world better, we can continue to have dialogues and continue to make friends. And of course, after I came back to Hong Kong, I had my own group, and during my first year, I managed to have a lot of very talented students who may be in different positions now. One of them was a visitor from France, and we continue to maintain very close working relationship, and later on became research collaborators. He is now a very well-known professor in university in the United States. And when I first came back to Hong Kong, I was also fortunate enough to be awarded the Early Career Award through the Research Grounds Council. And at that time, I was at the same ceremony with Professor Lap Chi Chui, who was also our president of the Hong Kong Academy of Science before Professor Low succeeded him. So, and then I continued to work in Hong Kong, in University of Hong Kong, to build my research lab. This is the research group. And we got to work with a lot of talented students that went on to have their own independent career in mainland China, in Hong Kong, in Europe, in different parts of the world. So it's great to be able to not just work with senior mentors, but also work with younger scientists, younger students to get inspired. So scientific career is really inspiring. And one of the things that I always feel very blessed about being able to work as a professor is that I get to work, and I get to learn, and I get to earn, and I also get to return to the society. So this, for those of you who are thinking about whether you may want to pursue a research career in future, this is something that you may want to consider as well. So why would someone be interested in research if you're considering doing research? My own journey tells me that there are multiple possible reasons. One is maybe there's some research questions that you're really curious about, so you may be driven by curiosity, and you may want to be helping to contribute in solving some problems. For example, during COVID, a lot of researchers quickly took up the task and try and come up with new ways to do detection, to do vaccines, etc. So there are lots of problems that need solutions. And if you want to contribute to a new solution, research is a very important element in the process. And of course, for those of us who enjoy doing research is fun. And also you get to develop a sense of rigor in tackling or in understanding some problems. So that is very, very helpful and important. And in the research process, we take a lot of criticisms, but criticisms, we learn how to have the right attitudes when we do research. When people criticize our work, people really help by criticizing our works, not by criticizing us as a person, because in the research world, we get a lot of feedbacks, we get a lot of what we call reviews, we get also a lot of rejections, whether when we publish papers or when we try to submit research grant proposal to get money to do research, we get lots of rejections. But the comments and the criticisms really help us enhance our rigor. So we do better research and we could become better researcher. And so we have to have a very open-minded mindset. Being open rather than defensive can allow us to get more questions, get more comments that can help us become better. And also in research, we do a lot of collaborations. We collaborate with different people. One thing that's important to remember when we collaborate is we want to have complementary expertise rather than overlapping expertise. We are not trying to get people to do our works, but we are trying to admit that we are weak in certain area. So we need people to collaborate with us so that we can move faster, we can move in the right directions by their feedbacks. And also to be good researchers, we also need to have a very strong focus. And this level of focus also will help us do better. So as you are thinking about or as you're participating in the research competition, do take that in mind. Some of these attitudes, some of these mindset will help you do better in your research project, in defining, in carrying out, in performing your research task. And hopefully that helps you to be more interested in science and discover how performing research is rewarding, and whether you become a researcher or not in future as a career. I think the process allowed you to acquire a research mindset with rigor, with spirit of collaborations, with an open-mindedness, so that you can take in a lot of feedbacks, comments, and even criticisms, and becoming better at what you're doing. So with that, I'd like to thank all of you and also take this chance to still wish you all a happy year of the snake and have a very fruitful year. Thank you.